Hi everyone. I am Adam Black, data scientist at Odysseus and aspiring Odyssey R developer, living and working in the real metaverse. Today I'm going to go through, I'm going to pick up where I left off on the dplyr database connector integration and and kind of show you how I'm thinking about making some changes in the database connector package to make it work with dplyr. And in particular, a lot of this centers around the DBI package. So I think that's where we'll start. And feel free to leave comments or questions. And yeah, let's get into it. So before I start on the package, I want to talk about DBI. So there's DBI is an R package which provides a unified interface to databases from R. This is a pretty old R package. It's been around for a while, and there's this nice um, vignette in the package on the history of DBI. In this vignette, David James describes how DBI was kind of in its current form around 2003, by around 2003, and that DBI was meant to unify the interface to relational database management systems so that our applications could be developed on top of DBI and not hard coded to any one relational database. As far as I know, all of the packages that connect to databases use DBI in R. Database Connector is a little bit different because it connects to multiple databases. There's a vignette in the DBI package about implementing a new backend. So it provides a standard interface to connect to databases. However, this is just an interface, so it has to be implemented for each specific database. And so there are several backend driver packages that provide the driver functionality for a number of databases. So one is R SQLite, one is R PostgreSQL, and there's many more. But this vignette kind of describes implementing a new backend database and the methods you have to implement. This webpage, db.rstudio.com, is helpful for learning about using databases from R. So we can see there are many database backends implemented, and all of these generally work with dplyr and have SQL translation associated with them. If we look at something like Postgres, you have the option of using the ODBC package or the R Postgres package. So the R Postgres implements a driver backend for Postgres databases. So here is the dbplyr package, and so this is the package that does the SQL translation for dplyr. And if we look in the files here, we have all of these backend files. So this is how the SQL translation is implemented for dplyr. So we can see that we have a backend R Postgres file, and these functions are based on the class of the connection object. So here we have PQ connection for Postgres. Since there are multiple packages that implement backend drivers, they duplicate these for like a PostgreSQL class. So to get these methods to work, our connection objects have to have a class. So in this case, if we have a Postgres connection, we need it to have a class of PostgreSQL. And then these translations should work. So this is the database connector structure, just very generally. It does export the DBI method, so it does implement DBI, but these are sitting on top of the database connector functions. So the database connector functions of connect and that connect and query to the database are at a lower level in the package than the DBI methods. And these are sitting on top of JDBC drivers for the case of most databases where we have a JDBC driver. We also have SQLite, which is using the R SQLite driver package. So most of the time when people are using Database Connector in Odyssey, they're skipping DBI entirely. They're just going through the Database Connector functions, which are things like create connection details and connect. So our path to the database, our path to querying the database in Odyssey tools largely does not go through DBI. So here we're looking at the connection classes in the DBI package and their inheritance. These are S4 classes in R. And we have a DBI connection class, which is defined in the DBI package. And we have a database connector connection, which is defined in the database connector package, which inherits from that. And then we have two subclasses. Database connector JDBC connection. So these are the connections for which database connector provides the actual driver, the JDBC driver. And then we have another class called database connector DBI connection, for which database connector does not provide the driver. And right now this is just SQLite. So this is where database connector relies on the our SQLite package for the actual driver functionality. But keep in mind that these are all DBI connections. So they're all inheriting from DBI connection. Here we're looking at the database connector driver classes. There is one driver class in database connector called database connector driver, and it inherits from DBI driver, which is defined in the DBI package. The reason why I'm talking so much about DBI is because I think this is really the root issue behind the dplyr working correctly, is that we have one driver class for all databases. So normally when we talk about a database driver, or the abstraction of a database driver, we have one driver for each database. So a driver is specific to a single database. The way that Database Connector implements this in R is that it has a single driver class which works on all databases. And so all the logic that has to kind of change how the driver behaves depending on the type of database is just coded into the methods for Database Connector driver. So what we need to do is create new classes for the driver, new driver classes and new connection classes for each specific database. This will allow us to use DBI more effectively and also allow dplyr to properly dispatch the methods for SQL translation. So this is the structure that I'm going to try to create. What I'm doing here is separating out the parts of Database Connector that are helper functions and the parts of Database Connector that are just like other driver packages in R. So Database Connector is kind of doing two things. It's acting like the driver packages, the difference being that it implements multiple drivers instead of just one. And it also has a number of helper functions. But what I'm trying to do here is make sure that all of the queries that we use through the database connector pass through this DBI interface. So this is the the idea of the interface, the DBI interface, is that it's a standard interface for talking to databases. And so we want to make sure that we're using that interface, uh, not just providing that interface, but actually using that interface. So the way I've kind of structured this is separating out Database Connector into two different conceptually into two different groups. One is the helper functions, which are going to use the DBI methods. We have implementations for the DBI methods, and then we have the backend driver methods, which are essentially the implementations of the DBI methods. And then when we're using something like RSQLite, we can just use that package directly. I think that this is also going to put this package on a firmer footing to be able to use other drivers and potentially give people the option to bring your own driver. So if you want to use ODBC or some other driver package like R Postgres, you could be able to use that as well with these database connector helper functions, which are how we're kind of connecting the database and querying it in all the OHDSI tools. This has a lot to do with getting dplyr to work, because we need new classes for each database connection. So now, instead of just having one JDBC connection class, we're going to have a new subclass for each database DBMS that's supported. And so we have a Redshift class, Postgres, SQL Server, Oracle, Parallel Data Warehouse, Netezza, BigQuery, and Spark. And these are all JDBC connection classes, because the database connector provides the JDBC driver to actually connect to and talk to the database. Now, for something like SQLite, we're using the RSQLite package. We still want this to inherit from the database connector connection class, because we want to make sure that it still uses the methods that we define for database connector connections. But it would be nice if it also inherited from SQLite connection. So here we have a multiple inheritance situation going on, where we'll have a new connection class, database connector SQLite connection, that inherits from both SQLite connection and database connector connection. Similar thing on the driver side. So we'll have new driver classes for each of the databases, and this will let us kind of use the standard interface for connecting to a database using DBI directly. So let's take a look at some code. Here I am in RStudio in the database connector package, and here's all the files in the database connector package. The ones that I am going to be working on are the connect file, and the DBI file, and the drivers file. Here we've got a nice function that lists out our supported databases. We have this create connection details function, which is used very heavily throughout OHDSI. This stores the username and password and connection information for a database. And one of the things that we need to pay attention to is anytime we are collecting a user's password and storing it. So what this is doing is collecting the expression and just storing the expression and not evaluating that expression. But anytime we want to evaluate it, we can by calling this password function. This is a little bit better than storing the actual password, because in some cases when we were storing the actual password, it would get printed out in log files, which is not good. So this at least prevents it from getting printed out in log files. However, I think anytime we're storing a password for any length of time, we have to be very careful. And in general, we want to consider these passwords extremely sensitive because they could be passwords to, any system. So we need to just assume that they're very sensitive. We have this connect function, and this is how most connections get made in OHDSI tools. And as you can see, it's split into these different branches. So if it's SQL Server, there's some branching logic here to build the connection string, and then we call connect using JDBC driver. If it's parallel data warehouse, we have some other logic to build the connection string, and similarly connect using JDBC driver. If it's Oracle, we have some other logic, and there's a try, and if it's an error, we try something else, and maybe we'll try a different OCI driver. And in each case, we're calling connect using JDBC driver with slightly different arguments. Here's Postgres. Again, connect using JDBC driver. Redshift. Netezza. Impala. So one interesting thing is Impala is not listed as a supported DBMS. So I don't think that this Impala section will ever get called, because when you call connect, we'll first call check if DBMS is supported, and Impala is not listed here, so the function will just give you an error. So it's really not clear if Impala is actually a supported DBMS. Hive also is not listed here, so that code will not ever get called. BigQuery. And then we have SQLite and SQLite Extended. The difference here between those two is that SQLite Extended uses this extended types argument, which tries to approximate using dates in SQLite. And it's not perfect, but it does let you kind of have dates in SQLite. And if we're using SQLite, then we call this other function connect using RSQLite. So we don't use the JDBC driver. And then finally Spark, we have a JDBC driver for that. Then we come to this function that everybody is calling, connect using JDBC driver. So this is actually creating the connection object, and this is some code that I put in there for just testing, but here's the main code. We create a new database connector JDBC connection object, and JConnection is that Java connection object. We have a few slots for identifier quote, string quote, DBMS, random string, register with RStudio, so it shows up in our database connection pane, and then return the connection. Then if we're using RSQLite, we essentially create an RSQLite connection using just the regular DBI interface. Then we use that to create a new database connector DBI connection object and embed that DBI connection into one of the slots in that object. And then DBI is where the DBI methods are defined. So we have a database connector driver class, and remember this is the class for all, this kind of represents all databases currently. So it's not specific to one database. We have a show method which allows it to print out, and a function that we use to create a new database connector driver object. Then we have the database connector connection object, which inherits from a DBI connection. And then there's two subclasses, database connector JDBC connection and database connector DBI connection. This is where I started working on adding a single subclass of the JDBC connection class. And then we see that the methods for dbConnect is just calling this connect function. So we can see that DBI is kind of sitting on top of database connector right now because its dbConnect method is calling connect. And similarly, dbDisconnect is calling disconnect. And there's several other implemented DBI methods in here. Something to pay attention to, I think, is when we're actually doing SQL translation inside database connector. So I think this is something to pay attention to, be careful of. It very tightly couples SQL render and database connector, and I think that it kind of violates the single responsibility principle, which is that there should be the driver's responsibility is purely to execute the SQL that it's given, and not be modifying that SQL. In this case, I think that it's fine. It's just something to think about. So one other thing I noticed when looking through this code is that when we make a connection to Postgres, we're actually storing the password, username and password expression inside the connection object. So this is a little bit strange to me. It says that it's used for bulk upload, so it could very well be useful when we're doing some bulk uploading, but again here we're storing the password, or in this case the expression that produces the password, which could just be a character string or a call to like an environment variable or something. But also what's strange to me is that no other database connector connections store the username and password, only Postgres. So it's so I'm wondering, maybe this section kind of warrants a little bit of discussion or thought around why do we store the username and password inside a Postgres connection but not inside other connections. All right, so I made some changes and I put them in a different branch. So we'll say git checkout DBI refactor. Okay, so we can go through these files again and look at the changes that I made. And if you notice here on this this pane here, we have kind of an outline of the file. So I think it's really one nice thing that RStudio does is if you put in these comments followed by these dashes, it will pick that up as kind of an outline. So I've broken the file into connection helper functions. So these are the functions that I'm thinking should sit on top of DBI, meaning they'll call DBI. And then the JDBC connection backend. So these are the things that sit behind DBI that implement the DBI that implement the DBI interface. DB connect methods, disconnect helper functions, and DB disconnect methods. And the functions are on here. The methods don't show up on here. So the things in bold are the headers, and each one is a function. So it's a nice way to kind of see the outline of the file and navigate through it. So we still have this this check if dbmess is supported function. I've commented out SQLite because I'm still a little unsure about how to actually implement this. The way that we were doing it, the way that it's currently implemented is that we're creating a DBI connection and then assigning it to a slot in a database connector DBI connection. What I'd like to do is just extend that connection object so that it's still a SQLite connection, but it also has the additional slots and attributes that make it a database connector connection. So we still have create connection details. So this function hasn't changed. We have our connect function. This first few lines here just say that if you pass in connection details, it will call the connect function, just parsing out each one of those arguments in connection details. But now this function is actually a lot shorter. So this is the entire connect function. And we use a switch to get the driver. So now we have all these different drivers, all these different driver constructors. We can see them in the drivers file now. So here, DBI driver classes. So here I added new classes for each of the database drivers. We still have our database connection driver, which inherits from DBI driver. We have an Oracle driver, and then the Oracle constructor, and then PostgreSQL driver, and a constructor for that, Redshift driver, constructor for that, SQL Server driver, Microsoft SQL Server driver, PDW driver. And the way that I'm thinking about these names is based on what we need the class names to be for dplyr to work. Okay, so we use a switch to get the driver object, and then we just call dbconnect. So now, instead of dbconnect calling connect, we have connect calling dbconnect. So connect is now sitting on top of dbconnect and using the DBI interface. We have connect using JDBC driver, and again I'm using a connection. I'm using a switch to get the connection class, and then creating a new object of that class. So I think those are defined, yeah, they're defined here in connection classes, in the DBI file, we have the database connector connection, which is the top level class that inherits from DBI connection. Then we have JDBC connection. So this is going to be a superclass of all of our database connection classes. And for each database, we have a new connection class. Okay, back to connect. So we get our connection class that we want to create, and then use new to create it. Then we look at, then we essentially I refactored that connection function into a bunch of dbconnect methods. So for the SQL Server driver class, when you call dbconnect, you'll call this method, and this is just the same logic, just copied into the dbconnect method for SQL Server driver. Similarly for PDW driver and Oracle driver. So this is not a huge refactoring. It's just putting these in their own methods rather than using the branching logic in the connect function. But what this means is that we'll be able to use database connector and the DBI, the standard DBI interface. So this is oftentimes how you connect to a database in R using the typical database backends. You make a call to dbconnect and then pass in the driver, and then all other connection to the database can go directly through the DBI package and the DBI interface. So you can see similarly here for dbconnect, we're passing in the driver. So what we should be able to do is use database connector : PostgreSQL inside dbconnect and be able to connect to a database that way. And then when we do that and we use dplyr, these methods will get called. So like, for example, SQL translation. Here is PQ connection, but it also gets assigned here to PostgreSQL. So we'll be calling this method when we use a database connector PostgreSQL connection with dplyr. Now for R SQLite, it's a little different because it's not a JDBC connection. So this logic is still kind of what existed in the previous, in the current version of Database Connector. We create a DBI connection, and then we're putting it into a connection slot. I think this is currently called DBI connection. And it's got the other slots that Database Connector has. But this doesn't quite seem right to me, because I think ideally this connection object would be would essentially be this object, but just be extended. So I'm still not quite sure how this should work. I think that the reason is that database connector connections should be kind of similar to to other DBI connections. In this case, we're sticking a DBI connection inside a database connector connection rather than having it actually extend the DBI connection. So that's the distinction. It's embedding a connection inside the object versus extending it. Here, disconnect is now calling DB disconnect instead of the other way around. And then we define DB disconnects on database connector JDBC connection class. So this will include all of the connection objects for any of the databases where we have the JDBC drivers. And in the case that they're not JDBC connections, then we just are calling DB disconnect in the DBI package. So we're just saying, okay, someone else has implemented the disconnect function, and we're just going to use that. Well, you made it through the second video in the Database Connector dplyr series. I hope you enjoyed it. I'm happy to hear questions, comments, suggestions, anything like that. I'd love to hear what you think of it, and I'll be making another video on testing and getting this code working, because there's still, I think, quite a lot more to do on this, as well as also I think I'm going to do some more foundational videos on just setting up tests, setting up the RStudio environment. And if there's a video that you want to see, just let me know, and I'll try to do my best to make it. So with that, I'll sign off, and I'll see you in the next one.